line is we set certain numbers on it by marks, and notice these are equally spaced marks, and we will number these 0, 1, 2, 3, 4, 5, 6, and so on, and we call these. Okay, let's look at some concepts of numbers. And so we'll start out with what is called the number line. The number line is we set certain numbers on it by marks, and notice these are equally spaced marks, and we will number these 0, 1, 2, 3, 4, 5, 6, and so on, and we call these the counting numbers. We also call them the natural numbers. We also call them positive integers, and then we have the number 0, and we have equally spaced marks on the number line which we call negative integers. Now we must understand the number line represents all numbers, so we're talking about numbers anywhere in between here. For instance, the 0.5, which is the same thing as 1/2, would be 1/2 the distance between the 0 and the 1. Or we can write numbers like fractions that say 1 and 1/2. This represents the number halfway between 1 and 2. Or we can have the integer or the whole number or the natural number that we call 3. Then we have what's called irrational numbers. The number pi you might be familiar with from some other math class. That's the number 3.14159. It goes on forever. So it's 3.14, so it's right in here a little after the 3. Or we have what's called rational numbers. Now, a rational number is any number that can be made as a fraction. So this is the same thing as 4 and 776 over 1,000. So it can be made to be a fraction, and it would be right in here close to 5. So the number line is just a line saying, okay, we have a bunch of numbers here, and we have words for all these. Now what we need to learn is what number is larger than another number. Well, what we say then is we're going to start at 0, and as we move to the right, the numbers are increasing. The numbers are getting larger. That means then 5 is greater than 3. That means 6 is larger than 0. That means 4 is larger than a -2. Now pay close attention to this. That means a -1 is larger than a -4. Now the numbers 1 and 4 aren't, but a -1 is larger than a -4 because we're defining numbers as getting larger or increasing as they go from the left to the right. So let's look and fill these in then. All right, this is saying that 10 is larger than 6. And the way we read this is greater than or less than. And we read 10 is greater than 6. We could read this 6 is less than 10. The largest number is on the open side of this symbol. The smallest number is on the closed side of it, or the arrow pointing, whichever way you want to think of it. But we read it 10 greater than 6. All right, and how would this one be? Well, -2 is greater than a -7. Go back and look at your number line. A -2 is over on this side of a -7. So -2 is greater than a -7. All right, 0 is greater than a -1. 7 is greater than a -2. 3.5, that's a negative and a positive. Now we don't have to look at the fractions on this one, since this is a negative number and a positive number. A positive number is larger than a negative number. So 2 1/3 is greater than minus 3 1/2. Now, here's something we want to learn, a new symbol. This says that something can be greater than or less than or equal to. So if they put a symbol in here, what you need to look at is if that's like that, equals. This is saying that this is less than or it could be equal to this number over here. Or this is saying this number is greater than or equal to that number over there. And that's what happens. 2/5 is the same thing as 0.4. We'll learn later on in other tapes about fractions and decimal numbers. But I want you to understand that when they put that mark underneath this greater than or less than sign, it means that this could be this or they might be equal. All right, let's look at a couple other examples. 1/2 greater than or less than 1/3. Now, let's do it by reasoning, if this is new to you at least. Let's consider we're on a number line, and this is at 0, and this is at 1. Now, 1/2 means that you've got one part out of 2. So we would end up dividing this into 2 parts. So 1/2 would be this distance. Whereas 1/3 says you have one part out of 3 parts. So we would end up dividing this into thirds, and we would only be using this one. So 1 out of 3 parts is less than 1 out of 2 parts. So therefore, we would write 1/2 is greater than 1/3. Now, you need to realize that you can read it either way, just knowing that the point points to the smallest one. All right, let's go down here and look at this next example. We have 1 1/2 and 1 4/6. All right, that again, that's saying that we're dividing, looking on the number line, from 1 over to 2. All right, 1/2 is dividing it up into one part out of 2 parts. And 4/6 is dividing it up into 6 parts. Let's see. 1, 2, 3, 4, 5, not equal, but there's 6, and so we're going to go 4 out of the 6. So therefore 4/6 is larger than 1/2. So this would then be 1 4/6 is greater than 1 1/2. Now, when you look at your tape on fractions, you're going to learn another way of finding this out a lot quicker. But I'm saying the reasoning of the number line can show you which numbers are larger. Now, let's look at this example which says which is largest, 1/3, 5/9, 1/2, or 7/15. Well, again, if we just use some reasoning on this from 0 to 1, this says we're going to go about 1/3 of the distance. Let's say that's approximately there. This is 1/2. Okay, so that marks that one out. 1/2 is bigger than 1/3, so we know we're right here. Now, 7/15. What is halfway of 15? 7 1/2. So this 7 over 15 is less than 1/2. So that's out. Now 5/9. 5/9, well, 4 1/2 is half of 9. So 4 1/2 would right here, so 5/9 would be over here somewhere. So therefore, 5/9 is the largest. Now, there's another way of doing this, and I would like to show it to you, but this reasoning process is sufficient to get the job done when you take an exam. One way of doing this is to get a common denominator, and what that means is we're going to get all these numbers to be the same. So 90 would be a common denominator. So we'll go back and multiply this by 30, and we would have 30 over 90. We go back and multiply this by 10, we would have 50 over 90. Go back and multiply this by 45, we would have 45 over 90. And go back and multiply this by 6, we'd have 42 over 90. All right, 42, 45, 50. 50 over 90. We have more parts out of the 90 than the rest of them do. So here's another question that you run across on the task test. It wants to know which number is larger. And a way to get there is reasoning. A way to get there is the number line. So, taking the number line in your thoughts, just know that the largest number is the one to the right. On the number line, the numbers increase as they go from left to right. All right, now let's look at one other concept, and that's what is called absolute value. The absolute value is denoted in most books and tests by two lines marked on each side of the number. Now forget what textbooks and all these words. What the absolute value says is simply throw away the minus sign and it's the answer. Okay. 3 minus 5 is a minus 2, and therefore the answer is a positive 2. Absolute value in concept is the positive value of the numerical number. The positive value of the numerical number. Now what that's important for is in a little while I'm going to discuss how we add and subtract signed numbers. And to do that, most textbooks refer to the words absolute value. So what I want you to know is simply this. The absolute value of a number is just the numerical number, just the number, not its plus and minus sign, just the number. Or what absolute value means is throw away the minus sign. To get numbers, that's what it means. When you get into algebra, then it has to be defined in a little different way, and you have to be a little more technical. But right here in this section of task test, all you want to know is the absolute value of the number is the positive value of the number. All right, now let's go to the concept of adding and subtracting and multiplying what are called signed numbers. So what we're going to do first is look at addition of signed numbers. Now what this means is when you have that little mark right there, that means a negative 2 number. Again, on the number line, it means a negative 2. That does not mean subtraction necessarily. And that's going to be one of your hard parts of reading exams and that type of thing is thinking sometimes signed numbers, not necessarily subtraction. All right, so let's look at the 4 cases of having 2 numbers to add. They can have either 2 positive numbers or unlike signed numbers. One is positive, one is negative, or the first one's negative, the second one's positive. But where one sign is different from the other one, where one sign is different from the other one. And in the last case, where they're both negative. Now, I'd like for you to notice this. These are the same rules. This one and this one is the same rule. It's when the signs are the same, I will give you that rule. The rule then when the signs are different is the other rule that I will give you. All right, now here are the rules. When the signs are the same, you simply add and take the sign of the numbers. These are positive, therefore the answer is positive. Now, if you put that little symbol in there, that's fine. There's nothing wrong with that. But you do not have to have that. All right, over here, when the signs are the same, you simply add the numbers and take the sign. I would like for you to think of numbers another way also. Think of signed numbers as money in the bank, your account, and a negative is a check that's written. If you have $4 in the bank and you write a $2 check, you're going to have $2 left in the bank. Whereas if you have $2 in the bank and you write a $4 check, you will be missing $2. Now here's the rule. When adding unlike sign numbers, you subtract the absolute values of the numbers. So 2 subtracted from 4 is 2. And then you take the sign of the largest. Now watch. When the signs are different, you subtract the numbers and take the sign of the largest absolute value number. All right, I got that up there. I want you to keep looking at it. I want to keep saying it. And get these two sentences in your mind. When the signs are the same, you simply add the number and take their sign. Add the numbers, take their sign. When the signs are different, you subtract the number and take the sign of the largest. Subtract the numbers, take the sign of the largest absolute value number. See? Now you got to realize that a -4 is not bigger than a 2, but I'm talking about the absolute value. You subtract the numbers, absolute values, and take the sign of the largest absolute value number. All right, let me give you 2 other examples. I said this would be $4 in the bank, you write a $2 check. $2 in the bank, write a $4 check. Another way of thinking of plus and minus numbers are like when they launch a rocket or a satellite or the space shuttle. Okay, the time before launch can be considered as 2 seconds or -2 seconds or -2 minutes. And the time after the launch is considered to be a positive number. Okay, so you can have negative numbers that have meaning in life. And to add them, this is what you do. Now what I have below here is the way that they're written in a lot of textbooks and exams. Instead of writing it this way, they're going to have it written this way. And what you need to realize, this means addition. 4 plus 2 is equal to 6. This means 4 plus a -2. When you do that, you have 4 plus a different sign, so you subtract the numbers and take the sign of the largest. This is a -4 added with a 2. Then we subtract the numbers and take the sign of the largest absolute value. Now looking at this one, there's 3 different ways that you'll see this written. You'll see a -4 added to a -2. So when the signs are the same, you add the numbers, take the sign. If you put parentheses in here, it's just a simple way of saying, look, I want you to think of this number and this number as 2 separate numbers. But this is the symbol you're looking at. It says addition. So you're adding same sign numbers, therefore you add the numbers, take their sign. And this is just another way that you'll see it in textbooks. All right, let's look at subtraction now of signed numbers. Now, you must notice in textbooks and tests how these little symbols are written. Sometimes that means subtraction. Other times they may put a symbol up there. That means a -2. So you must watch these things. They really mean the same thing, but at times they can confuse you. All right, so here's the rule for subtraction. The rule for subtraction is change the sign of the bottom one and add. Change the sign of the bottom one and add. Now, how do we add 4 and a -2? The answer is to subtract the numbers, take the sign of the largest, which is the 4. Let me say that again. I'm going to say it 4 or 5 times before this section's over with. To subtract, you change the sign of the bottom one and add. Now, don't be looking at this minus sign right here. Okay? That one was there to say subtract. To subtract, you change the sign of the bottom one and add. You change the sign of the bottom one and add. You change the sign of the bottom one and add. Use your addition rule. Change the sign of the bottom one and add. To subtract, you change the sign of the bottom one and add. Change the sign of the bottom one and add. Now, when it's written this way, when I say the bottom one, I'm talking about the one on the right of the subtraction sign. Now, this is a subtraction sign, so it says change the sign of the 2 and add, and so you get 2. Now, another way of looking at this, the way they'll write it in a lot of exam books, is they'll do this. Now, what that means is subtraction, not a minus, but a subtraction. Therefore, you use the rule, which says change the sign of this number and add. Use your addition rule. All right, so subtraction means to change the sign of this number and add. So we get a plus 6. Subtraction means change the sign and add. So we get a minus 6. Subtraction, see, this means a negative 4 here, but this means subtraction. So change the sign of this number and add. This means subtract, so it means change the sign and add. This means subtraction, so it says change the sign and add. Now, how do you add a plus 2 and a minus 4? Addition says if they're different signs, you subtract their absolute values and take the sign of the largest absolute value number. Now, keep looking at this, and here are the words. To subtract, you change the sign of this number right to the right of the subtraction sign, or the bottom number if they're written this way. Change the sign and then go back and look at the numbers and add those two numbers by the addition rules. This subtraction says go change the sign. Okay, go change the sign and then come back and add those two numbers. Change the sign and go back now and add those two numbers. This was a minus 2. Change the sign, so we change the sign and add those two numbers. All right, that's how you subtract sign numbers. Let's look at some more examples, the way you see them written in tests and textbooks and that type of thing. We have 16 minus 8. Okay, what that says then is subtract. Subtract 8 from 16, we get 8. Okay, you just kind of already know those type of things, all right? But still, the rule is you change this to a minus 8 and add that. And so you get a plus 8. All right, 5 minus 12 is a minus 7. Well, how do we get that? That's 5. And we change the sign of this to a minus 12 and add those. To add, when there are different signs, you get the difference in the numbers. The difference of the number is 7, and you take the sign of the largest absolute value. All right, looking at this one. This means subtract, so what do? We change the sign and we add. And so we get a plus 9. All right, now, when you have 3 numbers or more, don't make a big deal out of this. Just take your time and work 2 at a time. Take the first 2. 4 minus 2 is 2. And now 2 minus 7 is a minus 5. Another way of working it, a lot of people teach it this way. Add the numbers that are the same sign. What's a minus 2 and a minus 7 added? Well, that's a minus 9. And so now what's 4 minus 9? Same answer. All right, let's look at the next example. Now don't let parentheses throw you off. What this says is 12 subtract a minus 7. What is that rule? Change the sign and add. So that's 19 minus 3. And that answer then is 16. Okay, down here. All right. Subtraction says change the sign and add. Okay, changing the sign and adding here, we get a minus 2. Minus plus 1. Okay. This subtraction says what? Change the sign and add. What's a minus 2 added to a minus 1, which is a minus 3. Okay, if you're not comfortable with this, rewind the tape, watch it some more, go work some sample problems. All right, now let's look at multiplication. Now your reference book is going to give you some good ways of explaining it, but I would like to give you some mechanical statements that are very good to remember, that will hold true for you. And that is this: in multiplication, just multiply the numbers. 4 times 2 is 8. 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 Now you come back. Plus times a plus, still plus. Plus times a minus is a minus. Minus times a plus, minus. Minus times a minus, plus. That's one way of doing it. I like this better. In multiplication and or division also, if you have only one minus, the answer is minus. Or if you have 3 minuses, the answer is minus. Or if you have 5, if you have an odd number of minuses, the answer is minus. If you have an even number, which is 2 here, the answer is plus. So there's several ways of looking at this. One is a simple rule that says a plus times a minus is a minus. A plus times a minus is a minus. The other rule is a minus times a minus is a plus. I think the easiest way to do it, though, is simply in multiplication and or division. Now, this doesn't work for adding and subtracting. For multiplication and or division, if you have an odd number of minuses in the problem, the answer is minus. If you have an even number of minuses, the answer is positive. Let's look at some more examples. All right, here we have 3 times a minus 2. The answer is 6 for numbers. And then we have 1 minus, therefore the answer is minus. All right, let's look at the next one there. Minus 1.6 times 4.9, I believe that's 7.84. Now you have 1 minus, so the answer is a minus. Now there's another tape on how you multiply this, so don't worry about how I got that answer yet. Just a number times a number. I don't care what these numbers are. If you have 1 minus, the answer is minus. All right, let's look at this next example. 6 times 0 times a minus 2, and the answer is 0. Now the reason that the answer is 0 is 0 times any number is 0. In this level of mathematics, 0 times anything is 0. And so we do not worry about the minus sign. If you have a 0 in the problem and you're multiplying, the answer is 0. All right, next example. 3 times 4 is 12, times 2 is 24. So the answer is 24. Now we have what? 1, 2. That's an even number, so the answer is a positive 24. Now again, I'm not going to write these little positive symbols up here. Sometimes they do in textbooks. If you just write the number down, that's considered to be positive. So you do the numbers. Don't look at the minus numbers. It's 3 times 4 is 12 times 2 is 24. Come back, you have an even number of minuses. All right, let's take the next one. We do, see, what is it? 8 times 3 is 24 times 7 is 168. So this is 168. And we have 2 minuses, therefore the answer is a positive 168. If we had 3 minuses in here, which your notes have, then it's 3 minuses, therefore your answer is a negative 168. 1, 2, 3, odd number, therefore it's minus. Another way of doing this would be something like this. This times this would be a minus 24. Then times the minus 7. Minus times a minus is a plus, so it would be a plus 168. Then plus 168 times a minus 1 would be a minus 168. So you can do it step at a time, or you can just do the shortcut rule, which is this one. 3 times 3 is 9, times 3 is 27, times 3 is 81. Now you have 1, 2, 3, 4 negatives. That's even number, so the answer is a positive. So just look right here and let's say the rule. When multiplying sign numbers, you just multiply the numbers. 3 times 4 times 2, or 3 times 3 times 3 times 3, or 8 times 3 times 7 times 1. And if you have an odd number of minuses, the answer is negative. If you have an even number of minuses, the answer is positive. All right, let's move to division and look at the rules there. Well, the nice thing about division rule, it's the same rule as multiplication. The same rule. All right, 6 divided by 3 is equal to 2. 6 divided by 3 is equal to 2. Has 1 minus, so the answer is minus 2. 6 divided by 3 is equal to 2. Has 1 minus, so the answer is minus. 6 divided by 3 is equal to 2. Has 2 minuses, therefore the answer is positive. So it has the same rules as multiplication. All right, let's look at some other examples. This says 18 divided by minus 2. That says 18 divided by 2, so that's 9. Has 1 minus sign, so it's negative 9. Now you can write that minus 9 like that out in the front, or you can put the little sign up the top. It doesn't make any difference. Almost all textbooks will write the minus kind of out in the front, in the middle of the number, rather than up here at the top. You need to understand it means the same thing. What your difficulty can end up being is knowing whether this is a minus 9 or whether that's a subtraction symbol. And what you're going to have to do is take and work homework problems and get practice to get that down. You can't just read and look and know it. You have to do some homework and practice to get it understood. All right, next one. We have 49 divided by 7 is 7. Now we look at the minuses. There's even number, 2 of them. Therefore, the answer is a positive 7. All right, what is 4 times 3? Well, that's 12. Divided by 2 is 6. So the answer to this is 6. Now, 1 negative sign. So the answer is a minus 6. Now, it doesn't make any difference if you do it the way it's 4 times 3 divided by 2, or if you come along, if you know how to do things like this and divide out. Now, 2 times 3 is 6. Still 1 minus sign. I'm saying do not look at the minus signs. Do the numbers. Do multiplication, division. When you get through with that, then come back, and if you have 1 minus sign, the answer is minus. If you have 2 minus signs, the answer is positive. If you have 3 minus signs, the answer is negative. If you have 4 minus signs, the answer is positive. All right, looking at the last few examples. 4 times 3 is 12. Divided by 2 is 6. Have 1, 2, 3 negatives. Odd number, therefore the answer is a negative 6. Hey, you could have done it this way. What is a minus 4 times a minus 3? That's a plus 12. Now, what is a minus 2 divided into 12? Minus 6. Okay, this one. Now, what I want you to see the difference, or really not any difference between these two, is how they write it on paper. Here they put the parentheses, and over here they don't. It's still 4 times 3, which is 12, divided by 2, which is 6. 1, 2, minuses, therefore the answer is positive. All right, and the last problem, something you just need to know from now on, that you cannot divide by 0. If you have 0 in the denominator, then you need to write down things like not possible, does not have an answer, does not exist, no answer. Just know from now on that you cannot divide by 0. You can divide numbers into 0. Now the reason for this is this reason. 6 divided by 3 is equal to 2 because 2 times 3 is equal to 6. Division is a defined process. Somebody made it up and said this is the way it's going to be. Now, a lot of teachers try to explain a lot of reasonings for this. There's 2 3s in 6 and all that stuff. The reason of division is multiplication facts. If you know your multiplication facts, you have division. So if I come down here, what can I multiply times 0 that will give me 82? Well, there's not any number. You cannot take any number and multiply it times 0 and get 82. But you can take 0 and multiply it times 5 and get 0. So this is why if you have the 0 on the top, you can get answers. If you have 0 on the bottom, your answer must be not possible. See, we spend a lot of time trying to teach things for division where all you have to do is say, well, remember your multiplication facts, and then you know your answers. All right, this concludes this part of basic concepts. What you should do is stop this tape and work the example problems following the notes. Then look at tape 1B.